No. Thank you. Okay. Let me see. All right, here we go. If there's no more questions from homework or the quiz, right? I just got to make one more check. Okay. So here's what we're going to try to do. Okay. I think I'm going to have to use a pen just so it shows up, but you guys know better. Let's see how this works here, if this is going to work for me. Are you going to be able to come over here? Yes, you are. Come on. All right. All right. I think this should work. Yay, look at that. Ha ha. Ha ha ha. Sorry. How's that look? Does that look all right? No, it's all right. Hold on. I can make it better. Don't worry. Don't freak out. This will be one step, and then hold on. Don't worry. Don't worry too much. Shit. I'll worry a little bit. Here we go. Bam. Yeah. Look at that shit. Isn't that beautiful? All right. I think this should be good. And I can't make this come any closer. Yes, maybe a little bit. Okay. There we go. All right, guys. This is sort of a little bit of section 10.3 involves some graphing, which it really shouldn't, but oh well. Some polar graphing. I want to start off really, really nice. All right. Can somebody tell me? I'm going to use a little space. All right. Let me see. Don't look at that, Jeff. You got to look at your paper. Okay. Recall. Oh, that's going to be weird. Hold on. There we go. If I had to graph this on an XY plane, if I had to graph this, x equals 3, what would that look like on an XY plane? X equals 3.
Vertical line?
Yeah, careful. Yeah. Vertical line. Because x equals 3 doesn't give a shit what y is. Is there any restriction on what y can be?
No.
In this equation? No. The only restriction is on what x could be. So that's why when I draw this, does it leave out any value for y? No. Right? Do you guys understand what I'm saying? So every value y is picked up because there's no restriction on y in the equation. There's only a restriction on x. All right. And of course, the same thing for y equals would be a horizontal line. So what do you guys think? What about this equation? R equals 4. What variable is missing?
The y.
The angle.
Good. Theta is missing. Theta is missing. So remember how y was missing here and we picked up every value of y, but we just picked up everywhere that x is 3 on the way? Isn't this where x is 3? 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 Isn't it? Okay, Jeff. So what do you think this is going to mean? I don't care what theta is. Theta is going to be everything. I'm going to pick up every value of theta, but I have to run through all the points where r is 4.
So it's a circle.
It's a freaking circle. Shouldn't this be a circle? What does this mean? What does r mean?
The radius.
Radius. So I want to draw what points match this is every point where the radius is 4. Isn't that the definition of a circle? All the points that are an equidistance away from the center. In this case, from 0. So for example, if you want to get really down into the details, if I'm at 0 degrees, I want r equal to 1, 2, 3, 4. If I'm here, I want r equal to 4. If I'm here, I want r equal to 4. Well, screw it. I'm just going to pick up all the freaking points where r is 4. I'm going to make this circle. Whoop-de-frickin-doo. All right, sorry. Pretend like I did that correctly. Poor little thing. All right. And real quick, r equals 4 leads to r squared equals, if r is 4, r squared is?
16.
16. And what's r squared in x and y?
X squared plus y squared.
And this, of course, is the equation of a circle of radius 4. That has not been shifted. Okay, I like it. So that looks good so far, right? So far, that looks awesome. And that's really the only equation that's that nice. So, well, let me do this. Let me see if I can't use the same piece of paper. Maybe I can use, let's see if this green shows up. What about this equation? Theta equals, let's see if you guys get this. Theta equals pi over 6. So think about this, r equals 4. We picked up every possible value of theta, didn't we? We picked up every single possible value of the angle, but we stayed at 4 for r. This, what's going to happen here?
Is it a linear equation?
I swear to God, my hand is clean, but I look all dirty. Oh, well, too bad. Say again, sorry. I should listen instead of worry about my hands.
Is it like a linear equation?
It's okay. Yes, but let's not go quite there. You're a little ahead. So where is the? Give me one point where theta is pi over 6. Isn't that point theta equal pi over 6? Isn't this point theta equal pi over 6?
Yes.
All right. Let me see what you guys think. Is this point theta equal to pi over 6? Yes.
Yeah.
Just with a negative r, correct? Because remember, is r restricted in this equation? No. So it's the same way I picked up negative x's here and negative y's and positive y's. Here I'm going to pick up positive r's and negative r's. So like Rio said, this is the equation of a line at an angle of 30 degrees. Isn't that a little bit neat? All right, now you guys are going to help me out. You ready? You ready? Do you guys understand how that's a line? Same way that's a circle. I hold one variable constant and I just travel along the other variable. I hold one variable constant and I just travel along the other variable. So those are the two extremes, right? Hold r constant, hold theta constant. How's everybody doing so far? You guys okay out there? All right, I have to keep asking that because I can only see 2 of you, so I don't know. And then I only get answers from 2 of you, so that's all right.
I'm doing okay.
Thank you.
My camera isn't working right now, but I'm all right.
You're okay. I don't mean to make anybody feel guilty about not having a camera on. It's just my continued fight to maintain sanity. All right, let me think. Oh, here we go. All right, write this down. Theta equals pi over 6. Can somebody remind me what the, oh yeah, we got to do that too. Yeah, that'll be good. All right, I got a plan. Can somebody remind me what the conversions are? For example, r squared equals x squared plus y squared. What was the conversion for theta? How did I figure out what theta was?
R cosine squared.
No. Here's the conversion to figure out what r is if I know x and y. What's the conversion to figure out theta if I know x and y?
I thought you used cosine and sine.
No, come on. All right, I'll just tell you. Tangent theta equals, what's tangent theta equal?
Y over x.
All right, let me stop for a minute. All right, let me remind you of something. Hold on. All right, guys. Let me pull something up here real quick. So we're gonna go back and we're gonna do more from this in a minute, but I felt like we had to do this first because it has a lot of good stuff. Once you see some of the visuals of what's going on. Oh, I have exactly that one here. Dadgummit. I don't think we've done that yet, have we? I don't know. Remember this sheet? This here sheet, right? On Canvas. Remember this? Look. See. So if I know r and theta, this is how to convert to x and y. If I know x and y, this is how to convert to r and theta. Yes? Everybody with me? All right, now, and see how I actually have the same thing here. Oh, well, too bad for me. All right, so let's come back to this. I really want you guys to get this. This is so cool. All right. Where am I? Here we go. If I just take tangent of both sides, what do I get? What's tangent of pi over 6? Does somebody remember? Anybody?
Rad 3/3.
Yes, rad 3 over 3. And what is tangent theta in terms of x and y? It's y over x, correct? We multiply the x up, and don't I get this? You guys see that? Yeah. Don't I get this? Starting at theta equals pi over 6, I end up with this. And of course, this is the equation of a line going through the origin with the slope of rad 3 over 3, which is exactly what this is. Maybe. No, it sucks. You suck, Jeff. Screw you. Only you think this is good? It's okay, man. I'm used to it. All right. I don't know. Okay. All right. So let's do this. Let me think. We did do all. That's right. We did do all that. So I think we let's try a little bit more here. All right. Let's see what we can do here. Okay. This is where things are going to get interesting. I'm going to need some more room, unfortunately. So I'm going to have to go to another sheet here. All right. So I try to build us into this a little room for what I'm going to show you. All right, hold on. I need to see what I'm doing. Here we go. So I want to look at this equation here. And I want to plot, we're going to graph this equation. On polar coordinates. So this is a little scary. This is new. We're not really used to this, but watch this. This is going to feel very familiar. Okay, Jeff. What I'm going to do is I'm going to make a table of values. Now, it kind of sucks, to be really honest, that when we make points, we normally make them in r theta is the standard. Say the words, Jeff. It's the standard way we write that point in polar coordinates is r comma theta, which to me is really, really dumb because theta is more often the input. And how does x and y? Isn't x comma y input comma output? So I always thought this was kind of stupid. But so what I normally do is when I make a table of values, I go, let me do it over here. Theta r. Okay. Hopefully you guys are going to be cool with this. So what kind of makes sense here is I'm going to plug a 0 in. Now, can somebody help me out? When I plug a 0 into this equation, what do I get for r? Somebody who I haven't heard from yet, tell me. Don't make me call on you. I hate doing that shit. When you put a 0 in, what do you get?
Five.
Yes, because what's cosine of 0 is 1 times 5 is 5. That's crazy. All right. What about pi over 6?
Five
Say again, sorry.
5/02.
5 rad 3 over 2, right? I don't know if that's what you said. I might have misheard you. Now here, since we're doing this by hand, can somebody throw that in the calculator for me and round it to 1 decimal place because we're doing this by hand? Does that make sense? I can barely get 1 decimal place accuracy when I'm doing it by hand. Yes?
4.3.
4.3? That sounds about right. Is that what you guys get? Okay.
Yes.
So then pi over 4. That's going to be 5 rad 2 over 2, which I believe is going to be 3 let's see, Jeff, can you do it? 3.5 or 3.6, somewhere in there.
Yeah, 3.5.
3 point what?
5.
3.5? Okay, I like it. Now, real quick, let's go ahead and see. Can we plot these points we've gotten so far? So we have, to be honest, this would look like, officially, this would look like 5, 0. Everybody with me? See, I never know which way I want to do this because you guys have to know the convention. The convention is to put R first, theta second. But when I'm making a table of values, I normally kind of like to write it like this because it just makes more sense visually. I really hope I'm not going to screw you up by doing this. We'll have to just find out. Okay. So 0, 5. So how am I going to plot that point? What the shit does that point mean? How do I plot 0, 5? Or 5, 0, really? Come on, Jeff. Reinforce the right way. How do I plot 5, 0? Where do I face? What do I look at? And then how far do I walk? That's what you think, right?
So positive. 5 units.
Yeah, so I want to look at 0 degrees, 0 radians, actually, everything's in radians, and I want to walk out 5 in that direction, positive, right? So I'm going to look at him and then walk 1, 2, 3, 4, 5, the big circle, bam. So that's the point 5, 0, which is the same point on the XY axis, correct? Anyway, all right. All right, what about this point? 4.3. I need some more room. It's all right, Jeff. Screw it. 4.3 pi over 6. So I want to face pi over 6, and I want to go 4.3 out. So I'm going to have to estimate a little bit. 1, 2, 3, 4.3 is a little less than halfway, maybe about right there. All right. And then, of course, pi over 4, 3.5. So that's going to be a little bit easier. Face pi over 4 and go out 1, 2, 3.5. Kabam. All right, so I think you can see kind of like where this is going. Let's go ahead and plug pi over 2 in. This is a very simple equation. With more difficult equations, you actually might have to use these in-between points. So what do I get when I put pi over 2 in?
2.5.
No. What's cosine of pi over 2?
0.
I didn't say pi over 3. Yeah, I skipped pi over 3 because we can kind of see where this is going. And sure enough, it goes to 0. So it looks like this is doing this. All right, I like it. And you can probably guess what it's going to do from here on out, but let's just double check. So what about if I use 2 pi over 3? Now, real quick, pi over 3 would have been, like Rio said, it would have been 5 times a half, which is 2.5, which is about where 1, 2.5, which is about where I put it there, right? You guys see that? Now, 2 pi over 3, stay with me now. 2 pi over 3 is going to be related to this because they have the same reference angle, except what's true about cosine at 2 pi over 3, what's the value of cosine? What's true about it? It's true about cosine in the second quadrant. Okay,
Minus.
it's a half at a pi over 3 reference angle, but it's negative because it's in the second quadrant, correct? That's where x is negative. So let's see if this makes sense. Face 2 pi over 3, face this, but walk back 1/2. So it's going to be like right there. Is this right? Am I looking? Oh, I'm sorry. This is times 5, right? My bad. Everybody with me? Cosine is 1/2 times 5 is, so it should be negative 5/2. So I'm going to walk back 2.5. Let's see. 1, 2.5. So you're going to get mirror images of these points here. Is that, you guys understand what I'm saying there? You're going to have to, because all cosine's going to do now is it's going to cycle back through. So at 3 pi over 4, it's going to be the same as this, just negative. Do you guys all see that? Do you guys all understand? So the nice thing is you almost never have to do a complete table of values because of the fact that cosine and sine, all these trig functions kind of go through their values over and over. So you start to see a pattern after a while, and then you can kind of just keep going. So at 3 pi over 4, here it's going to go back. What is this? 1, 2, 3, and 3.5. So it's going to go back 3.5. 1, 2, 3.5. Bam, 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 bam. And then pi over 6, it's going to go 4.3. 1, 2, 3, 4.3. And then, of course, it's going to come back to here. So there it is. There's our circle. And we did this in the graphing calculator. I don't know if you guys remember. We did r equals something cosine. Does anyone remember what was different if this was 5 sine theta? Where would the circle have shown up if this would have been sine theta? Does anyone remember? Cosine likes x. Where would r equal 5 sine theta show up?
Y.
It would have been right here. Isn't that cool? Isn't that cool? No? Okay. Okay, maybe. All right, so before we go too much deeper into this, let's come back to this. Where'd it go, Jeff? Oh, you're gonna have to open the other thing. This is true. There it is. Yay. All right, let's see if this is gonna be too trippy for you. I don't want to move my camera because I'm gonna need it back here anyway. Tell me if this is too trippy. So the last time we did this much on this sheet, this is up on Canvas, right? The polar coordinate sheet. This is how much we did last time. We actually just did part B. Remember that on the sheet we just did? We did part B. So here, these are the important things up here. These you have to memorize. And to be honest, you already know all of this. You just haven't thought of it in this connection, in this way. What's weird about part C relative to all the conversions that we know? What's weird about part C?
Secant.
It's got freaking secant in it. Do I see secant anywhere in any of this shit? No. Stupid thing. So obviously, let's see if you guys agree this is obvious. How do I want to rewrite this? Somebody else tell me. How do I want to rewrite this to possibly be more useful?
3 then times 1 over cosine theta.
Okay. So I kind of took a little liberty with what you said, but hopefully you're okay with this. This still sucks, but at least it has a cosine now. Does anyone have a suggestion? Somebody else I haven't heard from. Do you have a suggestion on what to do now? What do I wish I saw next to cosine? Anybody? What do I wish I saw next to cosine? What would be awesome to see next to cosine? R, exactly. If I saw a freaking R next to cosine, that'd be nice. Do I want to multiply top and bottom by R, or is there a better way to make an R show up next to cosine? What else can I do with stupid cosine? It's really stupid. Look how it's on the bottom of things, stupid thing. What can I do to get rid of this cosine? And it also does other nice things for me. I know you guys can do this. Do you like the fact that this is a fraction with a trig function on the bottom? Do you like that? I mean, trig functions just suck, and this is on the bottom to top it all up. So how do I kill it? How do I make it not be on the bottom no more?
Divided by cosine or multiply?
It already is divided by cosine, so I'll have to go with your second thing. The way to kill cosine is to multiply by cosine. So what is r cosine theta? What is this? What is r cosine theta?
X.
X. So this is just the equation x equals 3. Okay. There was an animation I showed you where they were showing you cosine, sine, and all that as they were going around the circle. I don't know who remembers that secant was this line that just kept going up and down, because secant is related to a vertical line. Crazy. Okay.
Is this a circle?
What's that? Sorry.
Is it a vertical line or circle? Just
I was trying to remind you guys, there was an animation I showed you a while back. I have to find it again, but it was showing you where, like, as they went around the circle, it was showing you this is cosine, this is sine. It was showing you this is tangent, and it had secant hopping up and down, and it was just a straight up and down line. So I'll have to find that again, because now we see a deeper connection with that. Secant does seem to be connected to horizontal lines. I'm sorry, vertical lines. Okay. So let's see. Can you guys just do 3A for me? Just do it. Just do it. See how I'm asking you to convert two polar coordinates. So we start in rectangular, and I want you to convert two polar. So I don't know which set of these things you're going to use. I just don't know. So do number 3A. This is the thing I write all about. Yeah, it's neat. Right. All right, guys, I'm going to kind of catch up to you. So I just have to do this, square each piece. 3 plus 1 is 4. So what's R? Something. That's what it sounded like you said. What happened? I like that. Is that what just happened? Did somebody say something?
2.
2, yes. What about -2? Could it be -2?
Yes.
Totally. Now, here's the thing. This is an interesting discussion I had earlier in office hours. What quadrant is this point in? Of course. What quadrant is that in? Don't overthink it. What quadrant is the x and the y positive?
one.
It's in quadrant 1, correct? Here we go over and up. Okay, so it's in quadrant 1. So it's up to me. I'm just going to freaking pick positive r if it's up to me. If you picked negative r, you would have to pick the correct angle. It would have to be a negative angle or some other. It would be stupid. I wouldn't do that. I'd much rather tell somebody face this way and move this way, not face this other way and move back. I mean, that you can, but why? How am I going to get the angle? I got r. I need theta. How do I get theta?
Tangent.
Tangent. Yeah. To be honest, it's inverse tangent. So theta is the inverse tangent of y over x. And this is one you should know. This is something you should have memorized one way or another. We just had this angle show up earlier.
5/6.
Yes. Oh, somebody's in chat. Let me see if they got it. Yeah, they got it. Sweet. So this angle, this point can be written as 2 pi over 6. You could also write it as -2, 7 pi over 6. Or -2, -5 pi over 6. I mean, there's we talked about that a little bit. There's an infinite number of ways to, well, yes, there is an infinite number of ways to write this. All right, so you guys do part B. Don't forget, you got to consider what quadrant you're in. That's important. Okay, so let me double check with you guys. What quadrant is this point in?
Sec
Yeah, negative, positive. It's got to be in the second quadrant. So I got to be real careful that my angle and my R work together to get me there, right? So R is easy. What'd you guys get for R?
1.
1, which makes sense because isn't this, can't you guys just look at this point and tell me the angle it's at? Isn't it a unit circle point, right? And where is cosine and sine both rad 2 over 2? What reference angle?
Pi over 4.
Yeah, so because if I do this crazy ass theta is the inverse tangent of, I just get -1. And where's tangent some kind of 1? It's at a 45 degree, pi over 4 reference angle. Are you guys with me out there? And of course, what would that angle have to be? If I choose +1 for my R, what should I use for theta to get it in there?
3 pi over 4.
3 pi over 4. So I end up in the second quadrant. So my point is 1, 3 pi over 4. That's what it looks like in polar coordinates. All right. You guys doing okay? Yeah, okay. All right. Now this is kind of gross. This number 4. Here, I'll give you guys a light at the end of the tunnel here. We'll do number 4, and then I want to talk a little bit about this stuff, and then we'll call it a night. All right. So number 4A is kind of straightforward. There's not a lot to do to begin with, really, that's going to make anything better. So if I don't see anything I could do to simplify stuff, yes. But be careful, it equals -1. See this? Sorry, somebody's private chatting me, but right, because the ratio of these is -1, and that's really why it's got to be in this quadrant or that quadrant. Of course, I want it in this quadrant, and that's why. But the reference angle is definitely a pi over 4 reference angle for this. Okay, maybe. If I don't see anything to simplify, I'm just going to start replacing my x's and my y. What is y? Somebody else tell me. Somebody I haven't heard from yet. Well, I don't know. Anybody tell me. What is y in polar? I mean, we just know it. R sine theta, right? So y is r sine theta. And what's x?
R cosine theta.
Cosine theta. Now, one thing I could do is multiply this up. Is that cool? And I could divide the stuff down, but this is fine. This is not going to really do anything. You could even see like a double angle formula you could kind of use here. I mean, to be honest, you could do this. You ready? Oh, are you ready? I don't know if you're ready. Does anyone see that this is this? Because 2 sine theta cosine theta is sine 2 theta, so this must be 1/2 of that, because I don't see a 2 here. And then I could say r squared equals 2 cosecant 2 theta. I don't know if you can even see that, I'm sorry. This is fine though. This is a fine answer right here. You don't have to go any further. I really gave myself no room on this thing, did I? You really didn't, Jeff. You really didn't. Good job. All right. Look at C real quick. Look at C. And then maybe we'll do B. I don't know. We'll think about it. Can you simplify a little bit first to maybe bring something into play that's easy? If I see x squares and y squares, what am I hoping I can make? I really want you guys to get used to this, right? Because I know x squared plus y squared equals r squared. Is there a way for that to show up in here? Can I just do something to make that show up?
Yeah, you can send the negative square to the right. I mean, from the right side.
I'm gonna do this. I think this is
Oh, yeah.
basically what you're saying. Just add y squared, right? Okay.
Yeah.
All right. So what is x squared plus y squared? That's r squared, right? What is y over x?
Tangent.
Tangent theta. I like it. So there we go. Shabam. So don't just start blindly throwing r cosine theta and r sine theta in for x and y. That could make it much worse than it has to be. So that's what I mean. There wasn't really anything to do here. So that's what I just started. Just started throwing in r sine theta, r cosine theta, because there wasn't really anything to do. Here, if I add that over, that's r squared. Bam. Nice. Now, what do you guys think I need to do with part B? What do you think I need to do here? What should I do with this?
Shift 2.
No. I'm not trying to graph the circle. I'm trying to convert to polar form. Yeah, I want to not factor it out, FOIL it out. I want to multiply it out. And then I'm going to get x squared plus y squared in there with some other shit, right? You guys with me? If I FOIL this out, am I not going to get x squared plus y squared, which is a beautiful thing to see because it just becomes r squared. It just whoop, becomes r squared. All right, so I'm going to let you guys try this one out. We'll talk about that tomorrow. We are going to do stuff like this by hand. So we're gonna, I think, starting tomorrow, we're gonna continue using those these sheets, these polar sheets, or any polar graph paper that you like better. If you find something you like better, we're gonna use these, and we're gonna graph stuff like the limicon of Pascal or the ovals of Cassini. Although, you know, like put your ovals away, Cassini. Okay. So we are going to graph not just points, we're going to graph actual shapes. And I think I showed you how to do this stuff in your calculator. So, I mean, you know, you can play around with that too. Okay. I feel like tonight's a good night for an early release. So let's let's stop there. And you let me know if you need to hang out afterwards. Let me come back to life. Here I am. Otherwise, you're free to go, right?
Thanks, Professor. Have a good night.
Sure.
Thanks, Professor.
You're welcome. I'll see you guys tomorrow. Whew. Does anyone have any questions? You guys okay? All right. I'm going to head out. I don't know. What's it say? I've got everything up here planned out. Let's see what it says. May 17th, there is a quiz on May 17th, currently scheduled. Yes. Will it still be there by the time we get there? I don't know, but it's got a good chance to still be there. Okay. Okay. All right. I'm headed out. I'll see you guys